Just like humans, limits have rules they must obey. We need to assume the limit of f of x and g of x both exist. Then you get all these properties. After today, these will be second nature. I want to briefly discuss the last two as they are the easiest to conceptualize. Number 5 says the limit of a constant is the constant. You can look at the graph or think, does a constant ever change its value? And it doesn't. So the y value is always equal to c, and the limit is c. Next, the limit of x as x goes to a. Ask yourself, what happens to x as x goes to a? What happens to x as x goes to a? It goes to a. Therefore, the limit is a. Understanding this will help you have a good conceptual understanding of what limits are doing. Let's do an example. The limit as x goes to 1 of 3x squared minus 4. We'll carefully use our rules to expand this. Use the first rule to break over a difference, then the second rule to pull out the 3, then the third rule to pull out the squared, and finally rules 5 and 6. Our answer is 3 times 1 squared minus 4, or negative 1. A couple of things about this example. First, nobody does problems like this. Not even this guy. Look at our end result. We basically plugged 1 into the x value. This is how you should always start a limit problem. Plug in the limit value. If you get a number, you're done. There's a big exception here for piecewise functions, which are always a little strange. Second, notice how I wrote the limit at every step until I applied the limit. This is necessary. Here are some bad things you should not do. The first one is not writing limit. These are numbers. This is an expression. They are not equal. This one doesn't have anything inside the limit, so what are you taking the limit of? The last one doesn't tell you what x is getting close to, so how do you know what to plug in? Really try to avoid these. You'll just end up losing points and getting sad. Throughout this class, we're going to develop a whole bag of useful tricks. This is my bag. It's huge. Of course, I've been doing this a very long time, so of course my bag is big. I think that I have a bag for you in here, and I do. We're going to fill this bag with all sorts of useful tricks throughout the semester. And while your bag is small, it's not the size. Here's an example. The limit is x goes to 2 of x squared minus 4 over x squared minus x minus 2. At the moment, you only have one trick in your bag. Plug in the limit and see what happens. Plug in 2 and we get 0 over 0. It looks like our trick failed as this is not a number, but really it just tells us there's a new trick. If we get 0 over 0, we either need to factor, conjugate, or expand to try to cancel something. In this problem, it's a good idea to factor the top and bottom and cancel the x minus 2. This becomes a whole new problem, so we go back to our first trick and plug in 2. This time we get a number, 4 over 3, and we're done. That's our answer. Let's do another example. The limit as x goes to 1 of the square root of x minus 1 over x minus 1. Plug in 1 and get 0 over 0. I don't really want to factor this, but there is a square root on top. I'll multiply the top and bottom by the conjugate of the top. Remember, a conjugate is just changing the sign of one of the terms. Expand the side you conjugated, but not the side you aren't. Our goal is to cancel something. Don't make that more difficult. The x minus 1 cancels. Now we plug in 1 and get an answer of 1/2.